Testing, testing, 1, 2, 3. We are live on the channel. Hello. Does anyone hear me? See me? Feel me? Oh, we're live on the YouTubes. We are live on the YouTubes, folks. Close, okay. Thank you. I think we are. Yeah, we should be good. Can I lower this? This is kind of stupid. Okay, well, that's something. First YouTube stream. Let's see how this goes. We are live. Okay. Can everyone see me? Okay, well, let me just do a check here. We are doing a little test stream check. Check, 1, 2. Testing, 1, 2, 3. Check, 1, 2. Okay, cool. We are good. We're good in the hood. We are streaming. Okay, so yeah, first stream on the channel. Today I wanted to kind of go over some CES news. 2026 seems to be the year of humanoid robots, wearable technology, wearable artificial intelligence, getting one step closer to AGI, one step closer to quantum supremacy. There's so many exciting new things happening in the space right now, and I truly think that 2026 is one of those years that... How's the best way to put this? I just don't think there's ever been a technological revolution or advancement that we are about to experience ever since the Y2K era, and I think this is really going to topple that. So for, people coming up in the space, or people looking to invest, or people that are paying attention, I think now is a really great time for people to invest, really study kind of the next generation of, what this next revolution, I'm going to call it a technological revolution, for example, and just really kind of make smart, wise decisions about that. Because again, look what happened in the Y2K era, and with the rate that things are expanding and going with AI and robotics, and that's kind of the future of things. I think it's going to be a really, really exciting time. So in the meantime, I figured why not start jumping into CES by going over the NVIDIA press conference. I haven't watched it at all. I'm very curious to see what it's all about and what we're going to see. I always love watching Jensen speak, so I think this will be really interesting to watch, and I'm going to, live react and comment with you guys. So feel free to join in, tag along, hop in the chat if you guys have any questions. And, I look forward to just having a nice open discussion and seeing kind of what the latest and greatest tech is all about. So we're going to be talking about that. We're going to be talking about the new Asus X-Real 1 glasses. I know they have done a partnership. We're going to be talking about Atlas from Boston Dynamics and a couple other robots in the space. And if we have time later on, we'll talk about Claude, Anthropic, ChatGPT, a couple other things, some other wearable tech. So we'll see where we get going. But in the meantime, let me get this going. I'm going to put it on 2 times speed as well, or 1.25 at least. Let's see what we got here. Yeah, I'm assuming this is RTX footage here. Oh, Flight Simulator. There we go. Of course, Battlefield 6. For those who are following on the gaming channel, we've been playing a lot of Battlefield 6 recently. What's the next generation of AI? Physical AI. I'm telling you, 2026 is going to be the year of robotics. I think where humanoid robotics is right now is exactly where AI was about maybe like 3 to 5 years ago. And it seems like a lot of these companies are getting close in terms of like building, and especially like in terms of like developing just like that AI integration. But from my understanding, the biggest challenge with robotics that we face today is truly perfecting the hand. It really sounds like the human hand is truly just like a work of the art and one of a kind. And, creating fingers and being able to understand dexterity and textures and how much pressure to apply and adapting to certain materials and everything apparently is really special. And I have a feeling we'll probably see a lot of that today based on what's going on with this press conference. So we got a few robots here. And like, look how incredible this is. I think that was the Boston Dynamics Atlas robot that we just saw there. But look how incredible this is, just to see where robotics is now and to what scale it is. Like, there's factories in China that are just fully autonomous at this point that don't even turn on the lights. And I think it was the Ford CEO that even said when he came back from his last visit to China that he was just incredibly impressed by the level of autonomy and just by how advanced that their technology is over there. Not to mention their stuff's incredibly cheap. Okay. Little Earth 2. Oh, yeah, this is their Earth 2 project where they're trying to, like, recreate a digital Earth through artificial intelligence, which is kind of crazy because for those, conspiracy theorists that think the world is a simulation, this this is right up your alley, essentially.
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Here we go. The man, the myth, the legend himself with the jacket.
Hello, Las Vegas.
Oh, a new jacket. Crocodile skin?
Happy New Year. Welcome to CES. Well,
imagine doing this trade show right after Christmas, right after the holidays.
You got 3,000 people in this auditorium. There's
trying to relax, spend time with your family, and
there's another 1,000
then you have the
people
world's
apparently
biggest tech trade show like a couple days later. Crazy.
Show floors, all watching this keynote, and of course, millions around the world are going to be watching this to kick off this new year. Well, every 10 to 15 years, the computer industry resets. A new platform shift.
That is true. Every 10 years, it seems like the
PC to internet,
computer and tech world just completely flips upside down.
Each time, the world of applications target a new platform. That's why it's called a platform shift. You write new applications for a new computer. Except this time,
very true.
There are two simultaneous platform shifts, in fact, happening at the same time. While we now move to AI, applications are now going to be built on top of AI.
That is true. Speaking of, Claude Code is absolutely incredible for that. Not only myself, but a good chunk of my close friends that are in the software development space or DevOps space have told me they have Claude Code writing about 80 to 90% of their coding projects for them now, with them just kind of moderating or mitigating it. I don't think ChatGPT's codex has come anywhere close to where Claude Code is. And I think that's why there's a lot of people, including myself, very bullish on the Anthropic IPO for 2026, which I'm looking very, very forward to. We are an Anthropic family over in my household, that's for sure.
Computing has been fundamentally reshaped as a result of accelerated computing, as a result of artificial intelligence. Every single layer of that 5-layer cake is now being reinvented. Well, what that means is some $10 trillion or so of the last decade of computing is now being modernized to this new way of doing computing.
How crazy is that? $10 trillion we've spent on compute over the past 10 years.
Each year is going into modernize and inventing this new world. And what it means is $100 trillion of industry, several percent of which is R&D budget, is shifting over to artificial intelligence.
Yeah, I personally love Jensen's jacket. I think Jensen's got the best swag in the game for the billionaire race over here. I really dig the snakeskin. This must be honestly, if Jensen's rocking the snakeskin, this must mean a huge announcement for NVIDIA. There's definitely a new chip or a new TPU or GPU on the way. We'll see what happens here. Compute is AI. AI becomes agentic. Hold on. Compute is AI. AI becomes agentic. That's very true. That's kind of where we're at right now. Physical AI takes a leap. We're getting close. AI learns laws of nature. Open models reach frontier. Yeah, well, we're like I feel like all 5 of those things are slowly kind of taking effect. Some more ahead than others.
Keynote of the year. We're going to get the spider webs out. And so 2025 was an incredible year. It seemed like everything was happening all at the same time, and in fact, it probably was. The first thing, of course, is scaling laws. In 2015, the first language model that I thought was really going to make a difference made a huge difference. It was called BERT. 2017.
BERT. I've never heard of BERT. Chad, have you guys ever heard of BERT? BERT. I'm going to have to look that up.
It wasn't until 5 years later, 2022, that ChatGPT moment happened, and it awakened the world to the possibilities of artificial intelligence. Something very important.
ChatGPT was big. I was a little late to the game with ChatGPT, but over the past 2 years, I've really adopted, I think, almost the majority of the AI platforms into my everyday workflow, especially Claude.
Not only do we pre-train a model to learn, we post-train it with reinforcement learning so that it could learn skills. And now we also have test time scaling, which is another way of saying thinking.
NVIDIA has really shaped themselves from being like a hardware manufacturer to being an AI developer in all sides of the platform. Like, not only are they building hardware, but they're building software to marry that hardware together to better train AI systems.
To proliferate just about everywhere. Agentic models that have the ability to reason, look up information, do research, use tools, plan futures, simulate outcomes, all of a sudden started to solve very, very important problems. One of my favorite agentic models is called Cursor, which revolutionized the way we do software programming at NVIDIA. Agentic systems are going to really take off from here. Of course, there are other types of AI. We know that large language models isn't the only type of information. Wherever the universe has information, wherever the universe has structure.
Jensen has also mentioned in the past he's very bullish on small language models, and I agree with him. For 99% of the tasks that majority of everyday human beings are doing, push and pull requests, HTTP requests, locating information from an RSS feed or whatever it may be. You don't really need a large parameter model for that. You can honestly run that system locally, which would save you tons of money in compute as well. But again, not everyone has the compute capacity to run any sort of language model on their system. But again, SLMs are a lot more feasible to run on a local system. Just things to keep in mind.
When open innovation, when innovation across every single company and every industry around the world is activated at the same time, open models really took off last year. In fact, last year, we saw the
open models really did take off last year. I think for the people that had the money and the understanding of why open source is important, being able to run models offline, making sure your data is fully secure by your own self, and just being able to program and scale off an open source model is key. And that's as much as companies are trying to profit, just like look at Google, for example. Google's open source model model,
these
you know,
models
for
are getting smarter and
Chromium,
smarter.
for
Because of
Android.
that,
Look how much
you can see
Android
the
is
number of
scaled
downloads
because of
has
that,
exploded.
right? And
The
look
number
how
of downloads
behind
is
the
growing
App
so fast
Store
because
kind of
startups want
is
to participate
from
in the
what
AI
the Google
revolution.
platform,
Large companies
or
want
sorry,
to,
what the Google Store
researchers want
offers
to,
too, because
students want
you
to,
have a
just
lot
about
more
every single country
developers
wants
when
to.
things are open
How is
source.
it
You have a
possible
lot
that
more people
intelligence,
willing to
the
develop for the
digital form
system,
of
that have
intelligence, will
access
leave
for the
anyone
system.
behind? And so open models has really revolutionized artificial intelligence last year. This entire industry is going to be reshaped as a result of that. Now, we had this inkling some time ago. You might have heard that several years ago, we just started to...
Open models reach frontier. Yeah, so I think that's Kling up there. I could be wrong, actually. GBT. 8% of startups building on open models, 104 open. Okay.
build and operate our
agree.
own AI supercomputers. We call them DGX clouds. A lot of people asked, are you going into the cloud business? The answer is no. We're building these DGX supercomputers for our own use. Well, it turns out we have billions of dollars of supercomputers in operation so that we could develop our open models. I am so pleased with the work that we're doing. It is starting to...
Interesting. Damn, it's the highest.
attract
res.
attention all over the world and all over the industries because we are doing frontier AI model work in so many different domains. The work that we did...
Oh. Clara, biomedical AI. Earth 2, AI physics yet. Numatron, agentic. AI, Cosmos, physical AI, Groot, robotics. Alpha Mayo. Oh, yes, Alpha Mayo, I think, is the new one they are announcing, which is for autonomous vehicles. Okay, so this is going to be pretty interesting. So what you guys are looking at here, this is NVIDIA's entire ecosystem of AI products here. So these are 6 key factors of their business that you're going to want to pay attention to over the next few years. Clara, which, again, they're biomedical AI. Earth 2 is their AI physics, where they're trying to study the world and be able to rebuild it through artificial intelligence, which honestly I see a lot of potential coming from like the film and TV business. I could see that being a really popular asset, depending on if that's something they license out to productions or creators or people looking to build models in like Unreal Engine or whatever it may be. Numotron is their open source agentic AI system. Cosmos is their physical AI. I'm actually not too sure of what Cosmos is. I'd have to look into that a little bit more. Groot is their groundbreaking robotics AI platform. I believe that's what they're using to train a ton of different robotics models right now. I know they're training, I believe, Figure AI, the robots that Amazon is using in their warehouse. I forget the company that it is, though. Boston Dynamics they're doing as well. So, yeah, definitely something you'd want to pay attention to here.
in proteins in digital biology.
And
Lots of
Alpha
genes that you would
Numeo is
synthesize
their
and generate proteins.
new
OpenFlow 3 to
autonomous vehicle
understand
AI system,
understand
I
the structure of proteins. Evo 2, how to understand and generate multiple proteins, otherwise the beginnings of cellular representation. Earth 2, AI that understands the laws of physics. The work that we did with ForecastNet, the work that we did with CorDiff, really revolutionized the way that people are doing weather prediction.
Oh, it's for weather prediction. That's insane. And can you imagine once they marry a quantum computer to that and then can run all those possible weather simulations together? Like that's I think what I'm most excited for the most over the next couple of years of, you know, where technology is going. Like AGI is going to be really key in a lot of sectors and achieving that. But once you can marry AGI to a quantum computer, the results you're going to get and the answers you're going to get are going to be incredible. And it's not necessarily about finding the right answers, but it's about knowing all the wrong answers. And that's what I'm really, really excited for over the next couple of years, is about marrying AI to a quantum computer.
Nemotron, we've now doing groundbreaking work there. The first hybrid transformer SSM model that's incredibly fast and therefore can think for a very long time, or can think very quickly for not a very long time, and produce very, very smart, intelligent answers. Nemotron 3 is groundbreaking work, and you can expect us to deliver other versions of Nemotron 3 in the near future. Cosmos, a frontier, open, world foundation model, one that understands how the world works. Groot, a humanoid robotic system, articulation, mobility, locomotion, these models, these technologies are now being integrated, and in each one of these cases, open to the world. Frontier humanoid robotics models open to the world. And then today, we're going to talk.
So again, so Groot, Numatron, and Cosmos are all being integrated into a majority of humanoid robot platforms today. So NVIDIA, again, is really reshaped themselves, because a couple years ago, they were a GPU company for gaming. And then they ended up being a GPU. They had a new client in the GPU space, which was, you know, all the crypto miners buying all the graphics cards at the time. And now they've really reshaped themselves into being an AI developer platform. I've always said NVIDIA is the toolbox that developers need to build, and they keep proving that time and time again. And that's why they've hit a $4 trillion evaluation, and that's why Jensen continues to be such a successful CEO of the company.
Talk a little bit about Alpha Mayo, the work that we've been doing in self-driving cars. Not only do we open
Now, this is their new model, Alpha Mayo, for autonomous vehicles. And I believe they have a couple partnerships on this already, which I'm really excited about.
Trust how the models came to be. We open source all the models. We help you make.
Will Tesla and Uber take use of Alpha Mayo? I don't know. I'm really excited to see what partnerships they do have. I'm pretty sure they're tied up with Waymo, but let's find out.
Of AIs, so that you could process the data, you could generate data, you could train the model, you could create the model, evaluate the model, guardrail the model, all the way to deploying the model. Each one of these libraries are incredibly complex, and all of it is open source. And so now, on top of this platform, NVIDIA is a frontier.
And again, this is
AI
what's key
model
about open source, is just everyone being able to contribute to that model.
Open, so that we can enable every company, every industry, every country to be part of this AI revolution. I'm incredibly proud of the work that we're doing there. In fact, if you notice the charts, the chart shows that our contribution to this industry is bar none. And you're going to see us, in fact, continue to do that, if not accelerate. These models are also world-class. All systems are down. This never...
Imagine giving one of the world's biggest keynotes, and then your entire situation, or your entire PowerPoint just completely shits the bed. Let me just see where we are here. Okay, we're gonna get into some robotics soon.
Happens in Santa Clara. Is it because of Las Vegas? Somebody must have won a jackpot outside. All systems are down. Okay, I think my system's still down, but that's okay. I'll make it up as I.
Artificial intelligence, physical reasoning. Okay. I'm gonna skip over a little bit.
Inside, interpret what's inside, and help you read it. And so our PDF retrievers, our PDF parsers are world class. Our speech recognition models, absolutely world class. Our retrieval models, basically search, semantic search, AI search, the database engine of the modern AI era, world class. So we're on top of.
He's not wrong. NVIDIA truly keeps showing time and time again how much of a revolutionary leader they are in this space, and I don't think that's gonna go anywhere either, to be quite honest with you. I'm gonna speed this up a bit.
Leaderboards constantly. This is an area we're very proud of. And all of that is in service of your ability to build AI agents. This is really a groundbreaking area of development. You know, I first...
AI agents are something that I've started dabbling with on my personal time. Maybe another time I'll do a stream kind of showing you guys some of the stuff I'm building, as long as I don't look too stupid doing it, because again, I'm figuring a lot of this out for myself, but I understand the power of it. I understand the value of it. It's been a lot of fun to learn. It's not necessarily the cheapest thing to experiment with, but AI agents are truly the future. And as much as I hate to say it, this is where I see a lot of office style jobs getting kind of replaced, like secretaries, maybe people on the tech support side. It really depends, but the power of the AI agent is just absolutely insane from some of the things I've been seeing people build online. So we'll do a stream on that down the road, but again, I can't stress enough how cool AI agents really are.
When ChatGPT came out, people said, gosh, it produced really interesting results, but it hallucinated greatly. And the reason why it hallucinated, of course, it could memorize everything in the past, but it can't memorize everything in the
Do you guys remember when ChatGPT first came out and how bad it was at hallucinating? I remember that. I don't think ChatGPT got remotely usable until like, I want to say like 3.5. I might be wrong. I don't know. I don't have any issues now on like, what is it, 5.2? But yeah, the hallucinations way back when. But if there's anything I've learned, it's about, really about just creating projects, storing data inside of those projects, and then pulling from that project's data set. And that's really helped me limit hallucinations. But I am very specific on the information I feed my model.
future and the current, and so it needs to be grounded in research. It has to do fundamental research before it answers a question. The ability to reason about, do I have to do research? Do I have to use tools? How do I break up a problem into steps? Each one of these steps, something that the AI model knows how
Where
to do.
do I get a jacket like that?
together,
That's what
it's
I
able to
want to
compose
know.
it into
I
a
want to get
sequence of steps to
Could
perform
you
something that's never
imagine
done
if
before.
Jensen
Never
started
seen
his own jacket
This is the
company? That would
wonderful capability of
absolutely take
reasoning.
off.
We can encounter
The
a circumstance
Wong
we've never
jacket.
seen before and break it down into circumstances and knowledge or rules that we know how to do because we've experienced.
I
them
wonder
ourselves.
if he's going to
And so
bring
the
out
ability for AI
Elon
models
when
now
they
to be able
get
to
to
reason
the
incredibly powerful.
Alpha
The reasoning
Numeo
capability of agents open the
banter.
doors to all of these different applications. We no longer have to train an AI model to know everything on day one, just as we don't have to know everything on day one. That we should be able to, in every circumstance, reason about how to solve that problem. Large language models has now made this fundamental leap. The ability to use reinforcement learning and chain of thought, and, search and planning and all these different techniques in reinforcement learning has made it possible for us to have this basic capability. And it's also now completely open sourced. But the thing that's really terrific is another breakthrough that happened. And the first time I saw it was with Ervin's Perplexity, the search company, the AI search company.
Oh,
Really
don't even
innovative
get
company.
me started on Perplexity. I love Perplexity. I use Comet for everything. I'm literally on Comet right now watching this video. Perplexity is a really cool model, especially if you're doing deep research, deep learning. You can select what model's best for the task or let the task decide what model's best for you. But what's really cool about Perplexity, and excuse me if I'm wrong, but on top of what the model's information has access to, Perplexity also runs a scan through web search, peer review articles, and so much more to give you a much more accurate result when it comes to data research and collection. I really wanted Perplexity to buy Google Chrome a couple months ago. I really wanted that to go through. I thought that would have been really, really cool. I forget how much money they offered. I think it was like $35 billion. Excuse me if I'm wrong. Let me Google it really quick. But honestly, it's insane to see how Google has come back with Gemini. How much did Perplexity offer for Chrome? It's literally like the second thing in there. Yeah, $35 billion for Chrome. So you guys tell me in the chat if you guys think that, would have been, if you were Google, would you have sold or would you have held on? But Gemini to me has been, I don't use it that often, but it's by far been the most exciting model to watch come up in the space. Again, there's just certain things that Claude does for me that I don't think Gemini is nearly remotely there for. But if I were Sam Altman and if I were OpenAI, I'd be extremely concerned for Google this year. Google's now, I think, the second largest company in the S&P 500. On top of that, their model is incredible. It's absolutely up to par with 5.2 ChatGPT. And if anything, Google has a much better ecosystem of products and tools around and built around Gemini. They're going to integrate that hardware much faster and much better than OpenAI will and ever could. And I am really concerned for OpenAI this year. If they don't make, I think it's $88 billion they need to make in terms of, getting in terms of operating costs, profitability, able to keep their nonprofit status. And if they don't meet those targets this year, they're in big trouble. So we'll see what happens. Am I worried for NVIDIA? I don't know. Obviously, there's a huge investment from NVIDIA made into OpenAI, but at this current moment, I know there's a letter of intent signed, but I don't believe the deal's been signed. So I don't know. But all I know is if OpenAI doesn't succeed, Oracle and Mr. Softy, that's going to hurt because Microsoft owns 40% of OpenAI privately. So I don't know if I don't like how Sam Altman's always begging for handouts and, trying to get Trump to give him trying to get Trump to give him funding and all this other stuff. I understand, artificial intelligence dominance in the U.S. is a very important thing, but just, I don't know. All the other AI companies aren't struggling the way OpenAI is, and I think they've just taken way on too fast. And excuse my ramble onto that. We'll get back to this keynote, but I just figured that was a little important piece of context.
Time I realized they were using multiple models at the same time, I thought it was completely genius. Of course we would do that. Of course, an AI would also call upon all of the world's great AIs to solve the problem it wants to solve at any part of the reasoning chain. And this is the reason why AIs are really multimodal, meaning they understand speech and images and text and videos and 3D graphics and proteins. It's multimodal. It's also multi-model, meaning that they should be able to use any model that best fits the task. It is multi-cloud by definition, therefore, because these AI models are sitting in all these different places, and it also is hybrid cloud. Because if you're an enterprise company or you built a robot or whatever that device is, sometimes it's at the edge, sometimes a radio cell tower, maybe sometimes it's in an enterprise, or maybe it's a place where a hospital where you need to have the data in real time right next to you.
He makes a very good point. Real-time data is a real thing of importance at the moment.
Whatever those applications are, we know now this is what an AI application looks like in the future. Or another way to think about that, because future applications are built on AIs, this is the basic framework of future applications. This basic framework, this basic structure of agentic AIs that could do the things that I'm talking about, that is multi-model, has now turbocharged AI startups of all kinds. And
yeah, agentic AI is what the AI companies are truly looking to achieve right now. And agentic AI is really just a multi-nodal agent that can take advantage of so many different processes. So, for example, you have a push and pull request. You start with a push request where you're then searching through data from a certain website and then having a model, and you're pulling RSS feeds from those websites and then having that model organize that data into a spreadsheet, for example, connected to like a Google worksheet or something like that. Then you have that model make sure that none of that data is duplicated twice. It's checking dates and referencing that you have the most accurate data for the day. It then pushes you a summary to then your Gmail account, which then you're connected through an RSS request as well, which you're then doing a pull request for that data from that file system, and it's all connected through one model running that entire system off a certain trigger or whatever it may be. And that's usually probably a time of day or whatever it may be. But it's basically, the best way I can explain it is when you have a model being able to run multiple tasks in a sequence completely autonomously. That's the best way that I could explain it. And it's hard to see in this shot right now, but the photo that he has above of these nodes is exactly what I'm talking about. You have your file system, which is your data center, which is basically your data center. Your semantic search, which is what's filtering that data set.
All of the things that we do with open models is intended to do.
And all of this is going to be connected to a model. App data platforms, MCP, so if you wanted to connect that to Notion or some sort of app like Canva or something like that.
When you think about this architecture, what do you have? When you think about this architecture, all of a sudden you have an AI.
In my honest opinion, if there's anything I could recommend, kids growing up now try and get their best understanding of and learn, it's building an AI multimodal agent.
That you need to train that AI model. On the other hand, your AI is always at the frontier, by definition. You're always at the frontier on the one hand, you're always customized on the other hand, and it should just run. And so we thought we would make the simplest of examples to make it available to you. This entire framework we call a blueprint. And we have blueprints that are integrated into enterprise SaaS platforms all over the world, and we're really pleased with the progress. But what we do is show you a short example of something that anybody can do.
Let's build a personal assistant. I wanted to help me with my calendar, emails,
oh, here we go.
And even keep an eye
Is
on
that a DGX Spark on the table? It is. Oh, let's go. Found alias using NVIDIA Sync Spark. Let's go.
So I can use the same interface.
The Spark is so cool.
Or a DGX Spark. I use a Frontier Model API to easily get started.
It's an actual super AI supercomputer. I need to watch this step by step. This is actually insane. If you don't know what this thing is, it's really one of the coolest devices on the planet, and NVIDIA was so ahead of their time with this.
Emails, to-do lists, and even keep an eye on my home. I use Brev to turn my DGX
Accessing
Spark into a personal
Spark
cloud.
configure. I just wanted, okay, GPU.
Same interface, whether I'm using a cloud GPU or a DGX Spark. I use a Frontier.
Okay, so developers, you have your IDE here, your coding software. A lot of people are just going to be using VS Code for that. And then at the end of the day, yeah, again, so here's showing you just the cycle that this automation is going to be constantly running. So, you know, you're coding it in your IDE, you're selecting a reasoning model, you're giving it a plan, a tool to use, a critique, it's following back and forth, and then you're connecting it to whatever model you want. I actually use Anthropic and Google for a majority of my models. The X API is a real pain in the ass if you're not. I shouldn't say it's not a real pain in the ass, but they don't make it developer friendly for people on a budget. I will say that. OpenAI gives you a couple of free tokens, but to be honest with you, I don't really have any real reason for this. I've really been preferring Gemini for API keys over OpenAI API keys. And Anthropic is just incredible. 4.5 Haiku seems to be great. They have a lot of models that really don't take up a lot of token usage or cost too much. And at least for the stuff that I'm building, I really am not building anything complex where I need a great amount of reasoning or something like that. Maybe one or two of my automations down the road that I use for pulling stock information on a daily basis. I may use a deeper reasoning model, but again, I'll just have to evaluate the cost of that over time, because like I don't think a lot of people understand running automations isn't necessarily free. You have to host things on a server to an extent, or at least that's what I do on N8N, the platform that I use to build. But using a model, just like, you know, mining cryptocurrency, you are using a large amount of compute and you are burning what they call gas in the tech world. And, you know, gas is not free. I think everyone knows that when we're paying at the pump. And, you know, there's cheaper gas and there's better gas. What I'm using for a majority of my tools is regular gas, you know, regular 87% octane. That's what I'm powering my AI model with. There's very few things that I personally would need, you know, Supreme to power my model with, or anything, or to power my automation with. But there are a lot of advanced things that you can build that would need a larger reasoning model, just again for what majority of people would build. And I'll do another stream on this down the road if this is something that's really popular, because AI models are really cool once you start learning how to build them. But this is a really good kind of layout of just kind of what that would look like. You know, you're building in your, you a developer are building in your IDE connected to a cloud service. You're probably building over your GitHub repository as well. You know, you are using a reasoning model, creating a plan, using tools, and having the model critique itself. And then you are connecting that that task sequence, this automation basically, which could be different than what you see here, to a model, and then that's running off a trigger system.
Model API to easily get started.
Excuse my ranting, guys. I'm sorry if it's like too much here. I've been playing with AI a lot, so it's been a lot of fun to
so I have an open model that's running locally on the Spark
to kind of talk about and watch.
Now for any job, I want the agent to use the right model for the right task, so I'll use an intent-based model router.
So yeah, you can see he's choosing his model here, connecting it to the DGX Spark.
I want my assistant to interact with my world, so I'll hook it up to Hugging Face's Reachy mini robot. My agent controls the head, ears, and camera of the Reachy with tool calls.
Oh, this is cool. Okay, so they're building an agent, and then somehow...
DGX Spark.
Hey Reachy, what's on my to-do list today?
Your to-do list today.
I don't know much about Hugging Labs, or Hugging Face, whatever you mentioned.
Okay,
but 11 Labs is what he is using to create the voice of this robot.
Can you turn it into an architectural rendering?
Sure.
It's pretty cool how these robots, just using their camera and LiDAR technology, can then turn that into a compute process.
That's great. With Brev, I can share access to my Spark and Reachy, so I'm going to share it with Anna.
Hey Reachy, what's Potato up to?
He's on the couch. I remember you don't like this. I'll tell him to get off. Potato, off the couch.
This is cool. This is like having your own little R2-D2 or BB-8 at your side at all times. This is really cool.
Isn't that incredible? Now,
wow.
The amazing thing is, that is utterly trivial now. That is utterly trivial now. And yet, just a couple of years ago, all of that would have been impossible. Absolutely unimaginable. Well, this
Yep.
basic framework, this basic way of
It's
building applications
absolutely
using
incredible to
language models,
see, like, where we are right now with robotics and AI compared to where we were 3 to
Using
5
language
years
models.
ago, and it makes me so optimistic
language
for the
models,
future. It's
using language
insane.
models that are pre-trained and they're proprietary, they're frontier, combine it with customized language models into a agentic framework, a reasoning framework that allows you to access tools and files and maybe even connect to other agents. This is basically the architecture of AI applications. or
And again, what
applications in the modern
Jensen's
age.
talking
And the
about
ability
here
for
is
us to create-
marrying agents together, having one agent do this, another agent do that, and then, you know, having one agentic system oversee those different agents. But again, once agents are connected to a quantum computer, that's, in my opinion, where things are getting really crazy over the next 5 to 10 years.
These applications are incredibly fast. And notice, if you give it this application information that it's never seen before, or in a structure that is not represented exactly as you thought, it can still reason through it and make its best effort to reason through the data, the information, to try to understand how to solve the problem. Artificial intelligence. Okay, so this basic framework is now being integrated, and everything that I just described, we have the benefit of working with some of the world's leading enterprise platform companies. Palantir, for example.
Oh, here we go. Let's go,
their entire
Palantir.
Data processing platform is being
I got to
integrated
look into
solidly by NVIDIA.
Snowflake a
ServiceNow,
lot
the world's
more.
leading
I'm really not
customer
too
service
sure what
and,
they do as a
employee service
company.
platform. Snowflake, the world's top data platform in the cloud.
Edge video analytics. I really don't understand what they're doing with Palantir. I'm going to actually screenshot this and look this up more on my spare time, because this is actually really interesting to me. I'd love to know more about Snowflake, and I'm curious to know how their integration with Palantir works here, because it seems like they're marrying an AGI system here, or they're marrying Palantir to an AGI system here. IT and HR workflow automation. Okay.
Incredible work that is being done there. CodeRabbit, we're using CodeRabbit all over NVIDIA. CrowdStrike, creating AIs to detect, to find AI threats. NetApp, their data platform now has NVIDIA's semantic AI on top of it, an agentic system on top of it for them to do customer service. But the important thing is this: not only is this the way that you develop applications now, this is going to be the user interface of your platform. So whether it's Palantir or ServiceNow or Snowflake and many other companies that we're working with, the agentic system is the interface. It's no longer Excel with a bunch of squares that you enter information into. Maybe it's no longer just command line. All of that multimodality information is now possible, and the way you interact with your platform is much more, well, if you will, simple, like you're interacting with people. And so that's enterprise AI being revolutionized by agentic systems. The next thing is physical AI. This is an area that you've seen me talk about for several years. In fact, we've been working on this for 8 years. The question is, how do you take something that is intelligent inside a computer and interacts with you with screens and speakers to something that can interact with the world?
So this is what I'm trying to understand here. So their GB300 system, which I guess stores all their training, connected to Cosmos, which marries Alpha Numeo and Groot, which, I guess gets put into their Thor interface. Okay.
Can understand the common sense of how the world works.
Let's see if he explains
Object
this
permanence.
breakdown
If I
a
look
bit,
away,
'cause I'm actually curious
that
about
object is
this
still
too.
there. Causality. If I push it, it tips over. It understands friction and gravity. It understands inertia. That a heavy truck rolling down the road is going to need a little bit more time to stop. That a ball is going to keep on rolling. These ideas are common sense to even a little child, but for AI, it's completely unknown. And so we have to create a system that allows AIs to learn the common sense of the physical world, learn its laws, but also to be able to, of course, learn from data, and the data is quite scarce, and to be able to evaluate whether that AI is working, meaning it has to simulate in an environment. How does an AI know that the actions that it's performing is consistent with what it should do if it doesn't have the ability to simulate the response of the physical world back on its action?
Cosmo. Okay, I'm gonna skip ahead a little bit.
And simulation was really the foundations of almost everything that we've done with physical AI. So we have 3 computers and multiple stacks that run on these computers, these libraries, to make them useful. Omniverse is our digital twin, physically based simulation world. Cosmos, as I mentioned earlier, is our foundation model, not a foundation model for language, but a foundation model of the world. And it's also aligned with language. You can say something like, what's happening to the ball? And they'll tell you the ball's rolling down the street.
Right.
So a world foundation model, and then of course the robotics models. We have 2 of them. One of them is called Groot. The other one's called Alpamayo that I'm going to tell you about. Now,
Interesting. Okay. So yeah, it sounds like they marry all of their models together amongst. I'm just curious how RTX Pro is involved. I know, like, realistically, oh, they're running the simulations off the RTX. Okay. Storage, processing, that's the communication pathway through each. And the chip is the interface. I see now. Okay. See, and that's why we're here, guys. We learn things live together, which is really cool. Because again, as much as I'm a tech enthusiast, I didn't go to school for hardware engineering or software engineering. You know, I'm a film guy, and I just got into tech and, you know, programming and AI agents and building over the past few months to a year. And I've always been in the space, investing in tech and everything like that. So I figured, you know, why not, you know, create, you know, I have my own YouTube channel. I've never done anything with it. I figured why not use the platform to just kind of have an open conversation about some of this stuff.
Do with physical AI is to create the data to train the AI in the first place. Where does that data come from? Rather than, instead of having languages, because we created a bunch of texts that are what we consider ground truth that the AI can learn from, how do we teach an AI the ground truth of physics? There are lots and lots of videos, but hardly enough to capture the diversity and the type of interactions that we need. And so this is where great minds came together and transformed what used to be compute into data. Now, using synthetic data generation that is grounded and conditioned by the laws of physics, grounded and conditioned by ground truth.
Oh, that's
we
cool.
We can now selectively, cleverly generate data that we can then use to train the AI. So, for example, what comes into this
I
AI
wonder
is
if those
Cosmos AI
cameras are
robot on the
built
left,
into the
on
car,
over
or if
here,
those are
is
sensors on top
the
of
output
it.
of a traffic
Because like a
simulator.
Tesla would have
Now,
that
this
built
traffic
in.
simulator is hardly enough for an AI to learn from. We can take this,
Well, I don't know.
put it into a Cosmos foundation model, and generate surround video that is physically based and physically plausible that the AI can now learn from. And there are so many examples of this. Let me show you what Cosmos can do.
The
Oh
ChatGPT
my
moment for physical
lord.
AI is
Here we
nearly
go.
But the challenge is clear. The
I think
physical
I saw
world is diverse
Waymo up
and
there.
unpredictable.
Oh shit.
Collecting real-world training data
That
is
was
slow
crazy.
and
He
costly,
didn't hit him.
and it's never enough. The answer is synthetic data. It starts with NVIDIA Cosmos, an open frontier world foundation model for
This is
physical
so
AI.
cool. This is
Pre-trained
so
on
cool.
internet-scale video. real
This
driving
is
and
why
robotics
you
data,
should buy
and
more
3D
NVIDIA stock
simulation.
right here.
Cosmos learned a unified representation of the world, able to align language, images, 3D, and action. It performs physical AI skills like generation, reasoning, and trajectory prediction.
Wow.
From a single image, Cosmos generates realistic video.
Wow.
From 3D scene descriptions, physically coherent motion. From driving telemetry and sensor logs, surround video. From planning simulators, multi-camera environments. Or from scenario prompts, it brings edge cases to life.
Oh my.
Developers can run
Interesting.
interactive closed-loop simulations in Cosmos. When actions are made, the world responds. Cosmos reasons. It analyzes edge scenarios, breaks them down into familiar physical interactions, and reasons about what could happen next.
Interesting. Very
Cosmos
cool.
turns compute into data, training AVs for the long tail, and robots how to adapt for every scenario.
Very interesting.
I know, it's incredible.
They are really
Cosmos
becoming
is the world's
like they're not interested in building the robot, they're interested in building the brain, which I think is incredible because if there's any billionaire I trust with anything, it would be Jensen. I think he's the most kind-hearted, the most level-headed, the best to reason with, and everything he's done has just been out of his hope for humanity, honestly.
But doing it inside a computer. And we've made enormous progress. Today we're announcing Alpamayo, the world's first
This is
thinking,
cool.
reasoning autonomous vehicle AI.
Wow.
Alpamayo is trained end to end, literally from camera in to actuation out. The camera in, lots and lots of miles that are driven by itself, where humans drive it, using human demonstration, and we have lots and lots of miles that are generated by Cosmos. In addition to that, hundreds of thousands of examples are labeled very, very carefully so that we can teach the car how to drive. Alpamayo does something that's really special. Not only does it take sensor input and activates steering wheel, brakes, and acceleration, it also reasons about what action it is about to take. It tells you what action it's going to take, the reasons by which it came about that action, and then, of course, the trajectory. All of these.
So we got Eagle motion history, multi-camera video, obviously, optional user commands, trajectory. Okay.
Are coupled directly and trained very specifically by a large combination of human-trained and as well as Cosmos-generated data. the result of it is just really incredible. Not only does your car drive as you would expect it to drive, and it drives so naturally because it learned directly from human demonstrators, but in every single scenario, when it comes up to the scenario, it reasons about, it tells you what it's going to do, and it reasons about what it's about to do. Now, the reason why this is so important is because of the long tail of driving. It's impossible for us to simply collect every single possible scenario for everything that could ever happen in every single country, in every single circumstance that's possibly ever going to happen for all the population.
That is very true.
However,
Collecting worldwide
very
data
unlikely-
like
it's
that,
very
I can
likely
only imagine
that
it
every
poses
scenario
a big
that
challenge.
decomposed into a whole bunch of other smaller scenarios are quite normal for you to understand. And so these long tails will be decomposed into quite normal circumstances that the car knows how to deal with. It just needs to reason about it. And so let's take a look. Everything you're about to see is one shot. It's a no hands.
Routing to your destination.
Okay.
Buckle up.
Okay. What car are we in? I know it's a Mercedes, but it's a pedestrian. Okay. This is impressive. I'm not gonna lie. Protected yield pedestrian. Okay. Interesting. So it's good to know that it's reasoning behind the decisions it's doing behind the road, which is going to be great in terms of training future models. And again, these are all reasons why NVIDIA is a very large part of my portfolio personally. But again, Jensen just proves time and time again how much utility the company really offers, not only the world, but all the other tech companies looking to develop. Again, they are building the software that all these hardware companies need to build and expand on, and they do such a great job with it, and are always partnering with the right people for it. This is impressive. I can finally send emails in the car. Nudge for pedestrian. Okay. Wow. Very impressive.
How to guide the industry towards this new future, we have to get good at building the entire stack. Well, as I mentioned earlier, AI is a 5-layer cake. The lowest layer is land, power, and shell. In the case of robotics, the lowest layer is a car. The next layer above it is chips. GPUs, networking chips, CPUs, all that kind of stuff. The next layer above that is the infrastructure. That infrastructure, in this particular case, as I mentioned with physical AI, is Omniverse and Cosmos. And then above that are the models. And in the case of the models above that I just shown you, the model here is called AlphaMyo. And AlphaMyo today is open sourced. This incredible body of work, it took several thousand people. Our AV team is several thousand people, just to put in perspective. Our partner, Ola, I think Ola's here in the audience somewhere, Mercedes, agreed to partner with us 5 years ago to go make all of this possible. We imagined that someday 1 billion cars on the road will all be autonomous. You could either have it be a robo-taxi that you're orchestrating and renting from somebody, or you could own it and it's driving by itself, or you could decide to drive for yourself. And so, but every single car will have autonomous vehicle capability. Every single car will be AI powered. And so the model layer in this case is AlphaMyo, and the application above that is the Mercedes-Benz. Okay, and so this entire stack is our NVIDIA first entire stack endeavor. And we've been working on it for this entire time, and I'm just so happy that the first AV car from NVIDIA is going to be on the road in Q1, and then it goes Europe in Q2, here in the United States in Q1, then Europe in Q2, and I think it's Asia in Q3 and Q4. And the powerful thing is that we're going to keep on updating it with next versions of AlphaMyo and versions after that.
Yep.
There's no question in my mind now that this is going to be one of the largest robotics industries, and I'm so happy that we're working on it.
This is so cool.
It taught us an enormous amount about how to help the rest of the world build robotic systems. That deep understanding and knowing how to build it ourselves, building the entire infrastructure ourselves,
Hold on.
and knowing what kind
Let's
of chips.
go back. Let's go back a little bit here.
As I mentioned earlier, AI is a 5-layer cake. The lowest layer is land, power, and shell. In the case of robotics, the lowest layer is the car. The next layer above it is chips. GPUs, networking chips, CPUs, all that kind of stuff. The next layer above that is the infrastructure. That infrastructure, in this particular case, as I mentioned with physical AI, is Omniverse and Cosmos.
Oh, wow.
And then above that are the models. And in the case of the models above that I just shown you, the model here is called AlphaMyo. And AlphaMyo today is open sourced. This incredible body of work, it took several thousand people. Our AV team is several thousand people, just to put in perspective. Our partner, Ola, I think Ola's here in the audience somewhere, Mercedes, agreed to partner with us 5 years ago to go make all of this possible. We imagined that someday a billion cars on the road will all be autonomous. You could either have it be a robotaxi that you're orchestrating and renting from somebody, or you could own it and it's driving by itself, or you could decide to drive for yourself. And so, but every single car
Autonomous
will have
vehicles.
capability. Every single car will be AI powered. And so
He said it here first. Autonomous vehicles will be the biggest part of the robotic industry.
Okay, and so this entire stack is our NVIDIA first entire stack endeavor. And we've been working on it for this entire time, and I'm just so happy that the first AV car from NVIDIA is going to be on the road in Q1. And then it goes Europe in Q2, here in the United States in Q1, then Europe in Q2, and I think it's Asia in Q3 and Q4. And the powerful thing is that we're going to keep on updating it with next versions of Alpha Mayo and versions after that. There's no question in my mind now.
And it'll all be free because it's open source, baby. That's what's beautiful about, open source platforms. And
that deep understanding.
Jensen's just such a beauty. He really is.
And knowing what kind of chips a robotic system would need. In this particular case, dual Orins, the next generation dual Thors. These processors are designed for robotic systems and was designed for the highest level of safety capability. This car just got rated. It just went to production. The Mercedes-Benz CLA was just rated by NCAP, the world's safest car.
Wow, that's impressive. That's impressive. That is absolutely impressive.
Every single line of code, the chip, the system, every line of code, safety certified. The entire model system is based on sensors are diverse and redundant, and so is the self-driving car stack. The Alpha Mayo stack is trained end-to-end and has
Hold on, I'm really curious about something. Let's see how they're doing over the past couple days. Show me. So what do we got here? 182 at close the other day. Or sorry, 184.82 at close the other day. They've actually gone down recently. I thought they would have maybe jumped up with the news over the past month. So CES is right around here. So some build up to CES. Couple analyst ratings. Now we're at a new one here. Okay. Yeah, I don't know. It's going to be an interesting time to watch this climb in the robotics center. I don't think Waymo is publicly traded. Oh, yeah, they're private. I knew it. Can I see any listing? No. Lame. Well, yeah, NVIDIA is going to be fun to watch. Yeah, I'm a big fan of the company. Been owning it for a while, and I think this is going to be a whole new opportunity
incredible
for them.
Skills. However, nobody knows until you drive it forever that it's going to be perfectly safe. And so the way we guardrail that is with another software stack, an entire AV stack underneath. That entire AV stack is built to be fully traceable. And it's taken us some 5 years to build that, some 6-7 years actually, to build that second stack. These two software stacks are mirroring each other. And then we have a policy and safety evaluator to decide, is this something that I'm very confident and can reason about driving very safely? If so, I'm going to have Alpha Mayo do it. If it's a circumstance that I'm not very confident in, and the safety policy evaluator decides that we're going to go back to a simpler, safer guardrail system, then it goes back to the classical AV stack, where the only car in the world with both of these AV stacks running, and all safety systems should have diversity and redundancy. Well, our vision is that
that's incredible. They're running both systems, so it can be if you want it to run on like fully autonomous rules or have a regular sub-stack.
We build the entire stack together. We're going to deploy the car. We're going to operate the stack. We're going to maintain the stack for as long as we shall live. However, like everything else we do, now in some company.
Go. Oh, here we go. This is exactly what I wanted to see. Global L4 and robotaxi ecosystem building on NVIDIA. AV software, Aurora. I'm a big fan of this company. They're doing great stuff in the space. The company really needs some more visibility. I think it's really incredible with what they're achieving. They're kind of doing what NVIDIA is doing here. They're not necessarily focused on developing the driver. They're working on developing a vehicle. They're working on developing the driver. And they're partnered with Volvo. They're building autonomous trucks using a LiDAR style system on the Volvo truck, and it's fully automated, self-driving. Follow them on YouTube. Give them a sub, because every month they do these investor live streams for shareholders, where you can actually watch one of the truck deliveries live throughout the whole trip. Usually go across Texas from like Dallas to Austin or something like that. I'm from Canada, so geographically, I don't know if that's a long drive or not, but it's always really fun and really cool to see just how the system works live. They're doing some really cool stuff. So I'm really glad to see their name up here. Really, really glad. I haven't really heard of some of these other players, but I will look into them at some point. Obviously, Mercedes is up here. Stellantis, really glad to see them up there. Stellantis is a really cool player in the space. Uber, it's good to know Uber Technologies is building on that as well. Lucid, I'm not too sure about some of these other guys. Tier 1 and hardware partners. Sony, I imagine Sony's probably building some sort of sensor for them. And OmniVision's here too, which is interesting because these are two of the world's biggest sensor and sensor manufacturers, and Sony also does semiconductors. So this is kind of interesting to see. Bosch is up there too. Really cool to see. Foxconn. Interesting that Sony and OmniView. I wonder what each are doing. It'd be really nice to get some more clarity on that.
They pretty much just build the computers, the chips that are inside the car, and some companies work with us full stack, some companies work with us some partial part of that. Okay, so it doesn't matter how much you decide to use. My only request is use a little bit of NVIDIA wherever you can, and but the entire thing is open. Now, this is going to be the first large-scale mainstream physical AI market. And this is now, I think we can all agree, fully here. And this inflection point of going from not autonomous vehicles to autonomous vehicles is probably happening right about this time. In the next 10 years, I'm fairly certain a very, very large percentage of the world's cars will be autonomous or highly autonomous. But this basic technique that I just described in using the 3 computers, using synthetic data generation and simulation, applies to every form of robotics.
It's crazy to think about because it just hit me that my next car will probably be autonomous. Like there's a solid chance that, well, maybe not this car, but this or my next car will 100% be my last car that I'm driving based on what Jensen's saying here. And to be honest with you, I'm not really against that. Living in Toronto, traffic's a real pain in the butt. So my biggest complaint is always not being able to do emails or get some work done in the car, or, just it's good quiet alone time. You know what I mean? If you're going to make me sit through the traffic, let me enjoy it. But yeah, crazy to think that, my current car, and I have a really cool Subaru, might be my last car that I physically drive. So food for thought.
Systems. It could be a robot that is just an articulator, a manipulator. Maybe it's a mobile robot. Maybe it's a fully humanoid robot. And so the next journey, the next era for robotic systems is going to be robots. And these robots are going to come in all kinds of different sizes. And I invited some friends. Did they come?
Oh my God, what do we have going on here?
Hey guys.
Oh my God, what do we got here? This is sick.
Come on, hurry.
Is this from Star Wars?
Did you tell R2?
Oh, this is so cute.
Did you? And C-3PO?
I want one.
Okay, all right, come here. One of the things that's really, you have Jetsons. They have little Jetson computers inside them.
Oh
They're
my
trained
Lord.
inside Omniverse. And how about this? Let's show everybody the simulator that you guys learned how to.
I want one.
You guys want to look
How
at that?
much?
Okay, let's look at that. Run it, please.
I want one of these. This is cool. This is really cool. This is really cool.
Isn't that amazing?
Wow.
That's
Wow.
really a robot.
Oh, here we
You did it all
go.
inside Omniverse.
So
And the
I
robot's
can
simulator is
name
called
a
Isaac.
couple
Isaac's
of
an Isaac
these
lab,
off
and anybody
right
else
off
to build a
the
robot,
bat.
nobody's
This
gonna
guy
do
right
it.
here is
Now we
is
have
Am. Well,
look at all these
hold on.
friends that we have building robots. We're building big ones. No, like I said, nobody's as cute.
Here's the new Atlas robot. Amazon. I'm not sure who develops this though. I think this is a Rich Tech Robotics robot. I could be mistaken. I have no clue what the hell this thing is. I forget who makes this. This is a new CES product. That's a KUKA arm, obviously. Figure 03 robot. I think Waymo makes this thing. That's their little delivery bot. I'm surprised. Oh shit. I am stupid, and I didn't even see the elephant in the room. We got Cat back here. Do they have a new partnership with Cat? Because if that's the case, I'm buying the stock. Let me see what we're at right now. I'm looking it up on my. Actually, no. I should do this. I should let you guys see this. I'm sorry. I'm sorry. Let's take a look. Caterpillar. Okay, now we're talking. Over the past 5 days, yeah, well, I imagine CES was that nice bump. How GE, bro, good times could be. Caterpillar bringing AI smart autonomy. Yeah, that's from CES, I would assume. Stock market today, Dow, blah, blah, blah. Here we go. Maintains buy on Nvidia following CES. Well, yeah, obviously, Nvidia is not going anywhere anytime soon. Nvidia Corporation is one of the AI stock analysts are watching closely. January 6th, Bank of America. Stock by analysts highlighting Jensen Wong, robust demand for AI, blah, blah, blah. Yeah, Nvidia's current dominance in AI and compute. Nvidia campus. Hopefully Jensen talks about that a bit more, but that's really interesting news. 5-day. Yeah, so this is literally CES right here. 12. Yeah, that's insane. Literally the day before CES, end of CES, we dip again. Now we're studying out. Actually, we're almost at all-time highs again. That's not bad. 6 months, 53% year to date. Ooh, that's insane. They must have really died year to date. 1 year, not bad. Oh, okay. Honestly, not bad. No one's really competing with Caterpillar either, realistically. Definitely not a cheap stock though to buy. Would I buy Caterpillar? I absolutely would buy Caterpillar. I really don't have anyone in like the construction space. I do in like the rare earth minerals and mining side of things, but not on this side of things. Interesting. Let's take a look at their financials. Operating expenses. Okay. I won't bore you guys with this for this stream, but this is something I gotta look into later because yeah, it's not a terrible idea.
You guys out, but we have Neurobot and we have Agibot over there. You know, we have LG over here. They just announced a new robot.
Oh, LG's. Oh, is that LG's new robot?
Food to your house.
Crazy.
That's connected to Uber Eats, and that's Surf Robot. I love those guys. Agility, Boston Dynamics, incredible. You got surgical robots. You got manipulator robots from Franca. You got Universal Robotics robot, incredible number of different robots. And so this is the next chapter. We're going to talk a lot more about robotics in the future, but it's not just about the robots. In the end, I know everything's about you guys. It's about getting there. And one of the most important industries in the world that will be revolutionized by physical AI and AI physics.
This is such a flex, by the way, being like a keynote shareholder, like in this age of robotics, revealing like where the world's going in robotics right now. Like this is so crazy.
They're going to use for different physical plants and plant simulations. You got AI physics being integrated into these systems. So whether it's an EDA or SDA, and in the future robotic systems, we're going to have basically the same technology that made you guys possible. Now completely revolutionize these design stacks. Synopsys. Without Synopsys, Synopsys and Cadence
very cool.
Completely indispensable in the world of chip design. Synopsys is leads in logic design and IP. In the case of
hold on, targeting availability in every cloud and OEM. Interesting. AWS, CoreWeave, of course, Google Cloud.
They lead physical design.
All right, so all the main players, really.
And emulation and verification. Cadence is incredible at emulation and verification. Both of them are moving into the world of system design and system simulation. And so in the future, we're going to design your chips inside Cadence and inside Synopsys. We're going to design your systems and emulate the whole thing and simulate everything inside these tools. That's your future. We're going to you're going to be born inside these platforms. Pretty amazing, right? And so
that's so crazy. They're going to build in. That's insane. They're going to build this AGI into these systems.
Simulation industries, Synopsys and Cadence. And today we're announcing that Siemens is also doing the same thing. We're going to integrate CUDA-X physical AI, agentic AI, Nemotron, deeply integrated into the world of Siemens. And the reason for that is this. First, we designed the chips, and all of it in the future will be accelerated by NVIDIA. You're going to be very happy about that. We're going to have agentic chip designers and system designers working with us, helping us do design, just as we have agentic software engineers helping our software engineers code today. And so we'll have agentic chip designers and system designers. We're going to create you inside this. But then we have to build you. We have to build the plants, the factories that manufacture you. We have to design the manufacturing lines that assemble all of you. And these manufacturing plants are going to be essentially gigantic robots. Incredible, isn't that right? I know. And so you're going to be designed in a computer. You're going to be
These robots are so cute. I want one so bad. This is insane.
Long before you have to spend any time dealing with gravity.
This is absolutely insane.
Do you know how to deal with gravity? Can you jump? Can you jump?
Very cool.
All right,
As the world builds factories of every kind for chips, computers,
Here we
life-saving
go.
drugs, and
Here
AI.
we go.
As
This
the
is
global labor
more
shortage
partnerships.
I
These
know.
are good to know.
Do you know how to deal with gravity?
All these names are
Can you jump?
things people should keep in mind.
Let's take a look at the stuff that we're going to do with Siemens. Come on.
Breakthroughs in physical AI are letting AI move from screens to our physical world. And just in time, as the world builds factories of every kind for chips, computers, life-saving drugs, and AI. As the global labor shortage worsens, we need automation powered by physical AI and robotics more than ever. This, where AI meets the world's largest physical industries, is the foundation of NVIDIA and Siemens partnership. For nearly 2 centuries, Siemens has built the world's industries. And now, it is reinventing it for the age of AI. Siemens is integrating NVIDIA CUDA-X libraries, AI models, and Omniverse into its portfolio of EDA, CAE, and digital twin tools and platforms. Together, we're bringing physical AI to the full industrial lifecycle. From design and simulation to production and operations. We stand at the beginning of a new industrial revolution, the age of physical AI, built by NVIDIA and Siemens for the next age of
Wow,
industries.
this is impressive.
Incredible, right, guys?
This is very
What do you think?
impressive.
All right, hang on tight. Just hang on tight. And so this is, if you look at the world's models, there's no question OpenAI is the leading token generator today. More OpenAI tokens are generated than just about anything else. The second largest is probably open models. And my guess is that over time, because there are so many companies, so many researchers, so many different types of domains and modalities, that open source models will be by far the largest.
Oh,
Let's talk about somebody really
I
special.
agree
You guys wanna do that?
completely. I think open
Let's talk
source
about Vera Rubin.
models will become the
Vera Rubin.
biggest
Yeah, go
models
ahead.
there
She's
are.
an American
Absolutely.
astronomer. She was the first to observe.
Like
She
that
noticed
really
that
only
the
makes
tails of the
sense because of
galaxies
how many
were
people
moving
can
about as
contribute
fast
to that model.
as the center of the galaxy. Okay, Vera Rubin is designed to address
Insane demand for AI computing. Yeah, I agree with you, and it's like we're getting to a point. Yeah, exactly. Token cost. This is exactly the point I was gonna say. We're getting to a point where, all the models are getting so damn good. It's really just about making them more efficient, and now you're starting to see that here. And with again, these open source models end up being some of the cheaper ones to run. Yeah, GBT sucks, honestly. That's honestly, and again, that's part of the reason I actually don't use GBT models for a lot of my API token use, because again, it's just like the compute is just so expensive compared to what anyone else is doing, and like honestly, I'm just not a fan.
The amount of computation necessary for AI is skyrocketing. The demand for NVIDIA GPUs is skyrocketing. It's skyrocketing because models are increasing by a factor of 10, an order of a magnitude every single year.
Yeah,
And
the
not to mention, as I
demand
mentioned,
for
O1
chips is
introduction
just
is an inflection
absolutely
point for AI.
insane.
Instead of a
That's
one-shot
not
answer,
going away
inference
anytime
is
soon.
now
Now
a
it's
thinking
officially the
process.
worst time
And
on
in
the
order to
planet
teach
to
the AI how
ever
think,
buy
reinforcement
a
learning,
GPU
very
between,
significant computation was introduced
or
as
sorry,
part
buy a
of it. It was
PC
no longer-
between
it's
the
no longer
doubling in
supervised
GPU
fine-tuning,
prices
or otherwise
and
known as
RAM
experimentation
recently.
learning,
Not to
supervision
mention
training.
SSD
You
storage
now
is
have
now
reinforcement
going up
learning,
too.
essentially that we have to advance the state of the art of computation every single year, not 1 year left behind. And now we've been shipping GB200s a year and a half ago. Right now we're in full-scale manufacturing of GB300, and if Vera Rubin is going to be in time for this year, it must be in production by now. And so today I can tell you that Vera Rubin is in full production.
Very cool.
You guys want to take a look at Vera Rubin? All right, come on. Play it, please.
Vera Rubin arrives just in time for the next frontier of AI. This is the story of how we built it.
This is cool.
The architecture, a system of 6 chips, engineered to work as one, born from extreme co-design. It begins with Vera,
Oh
a custom-designed
my Lord.
CPU, double the performance of the previous generation, and the Rubin GPU. Vera and Rubin are co-designed from the start to bidirectionally and coherently share data faster.
Wait, hold on. What did I just frickin' see there? 5 times Blackwell. Oh my god, this is absolutely insane. It's 5 times faster than Blackwell is.
and Rubin are co-designed
That's
from the start to
crazy.
bidirectionally and coherently share data faster and with lower latency. Then, 17,000 components come together on a Vera Rubin compute board. High-speed robots place components with micron precision before the Vera CPU and 2 Rubin GPUs complete the assembly, capable of delivering 100 petaflops of AI, 5 times that of its predecessor. AI needs data, fast. Connect X9 delivers 1.6 terabits per second of scale-out bandwidth to each GPU. Bluefield 4 DPU offloads storage and security, so compute stays fully focused on AI. The Vera Rubin compute tray, completely redesigned with no cables, hoses, or fans, featuring a Bluefield 4 DPU, 8 Connect X9 NICs, 2 Vera CPUs, and 4 Rubin GPUs. The compute building block of the Vera Rubin AI supercomputer. Next, the 6th generation NVLink switch.
Wow.
Moving more data than the global internet, connecting 18 compute nodes, scaling up to 72 Rubin GPUs, operating as one. Then, Spectrum X Ethernet Photonics. The world's first Ethernet switch with 512 lanes and 200 gigabit capable co-packaged optics scale out thousands of racks into an AI factory. 15,000 engineer years since design began, the first Vera Rubin NVL72 rack comes online. 6 breakthrough chips, 18 compute trays, 9 NVLink switch trays, 220 trillion transistors, weighing nearly 2 tons.
This is absolutely
One giant
incredible.
leap to the next
Holy
frontier
crap.
of AI. Rubin is here.
Holy crap. That's insane. That's absolutely
What do you guys
insane.
This is a Rubin pod, 1,152 GPUs in 16 racks. Each
Oh
one of the
my
racks,
God.
as you know, has a 72 Vera Rubin, or 72 Rubins. Each one of the Rubins is 2 actual GPU dies connected together. I'm going to show it to you. But there are several things that, well, I'll tell you later. I can't tell you everything right away. Well, we designed 6 different chips. First of all, we have a rule inside our company, and it's a good rule. No new generation should have more than 1 or 2 chips change. But the problem is this. As you can see, we were describing the total number of transistors in each one of the chips that were being described, and we know that Moore's law has largely slowed. And so the number of transistors we can get year after year after year can't possibly keep
He's
up
very right about
with
this,
the
by
10
the way.
times larger models. It can't possibly keep up with 5 times per year more tokens generated. It can't possibly keep up with the fact that
He makes a good point. What he's pointing out right now is that at the current rate of development that NVIDIA and other companies are building chips, it's not going to be able to keep up with the world's demand of compute. So what he's saying here is that they basically broke their rule of developing 1 chip per year, and they ended up developing, I think, 6 this year. So he might explain this a bit more, but that's more or less kind of what Jensen's getting to here.
cost decline of the tokens are going to be so aggressive. It is impossible to keep up with those kind of rates if for the industry to continue to advance unless we deploy aggressive, extreme co-design, basically innovating across all of the chips, across the entire stack, all at the same time. Which is the reason why we decided that this generation, we had no choice but to design every chip over again. Now, every single
That's
chip that we were
incredible,
describing
by
just
the
now
way.
can be a press
6
conference
chips
in
in
all
one,
itself. And
6
there's an
chips
entire
in one
company that's
generation.
dedicated to
Just
doing that
never
back in the
been
old
done
days.
before. That's
Each one of them
absolutely
completely
insane.
revolutionary and the best of its kind. The Vera CPU, I'm so proud of it. In a power-constrained world, Gray CPU is 2 times the performance. In a power-constrained world, it's twice the performance per watt of the world's most advanced CPUs. Its data rate is insane. It was designed to process supercomputers. And Vera was an incredible GPU. Grace was an incredible GPU. Now Vera increases the single-threaded performance, increases the capacity of the memory, increases everything just dramatically. It's a giant chip. This is the Vera CPU. This is one CPU. And this is connected to the Rubin GPU. Look at that thing. It's a giant chip. Now, the thing that's really special, and I'll go through these. It's going to take 3 hands, I think, 4 hands to do this. Okay, so this is the Vera CPU. It's got 88 CPU cores, and the CPU cores are designed to be multi-threaded. But the multi-threaded nature of Vera was designed so that each one of the 176 threads could get its full performance. So it's essentially as if there's 176 cores, but only 88 physical cores. So these cores were designed in using a technology called spatial multi-threading. But the I/O performance is incredible. This is the Rubin GPU. It's 5x Blackwell in floating performance. But the important thing is go to the bottom line. The bottom line is only 1.6 times the number of transistors of Blackwell. That kind of tells you something about the levels of semiconductor physics today. If we don't do co-design, if we don't do extreme co-design at the level of basically every single chip, across the entire system, how is it possible we deliver performance levels that is, at best 1.6 times each year? Because that's the total number of transistors you have. And even if you were to have a little bit more performance per transistor, say 25%, it's impossible to get 100% yield out of the number of transistors you get. And so 1.6x kind of puts a ceiling on how far performance can go each year unless you do something extreme, and we call it extreme co-design. Well, one of the things that we did, and it was a great invention, is called NVFP4 tensor core. The transformer engine inside our chip is not just a 4-bit floating point number somehow that we put into the data path. It is an entire processor, a processing unit that understands how to dynamically, adaptively adjust its precision and structure to deal with different levels of the transformer so that you can achieve higher throughput wherever it's possible to lose precision and to go back to the highest possible precision wherever you need to. That ability to dynamically do that. You can't do this in software because obviously it's just running too fast. And so you have to be able to do it adaptively inside the processor. That's what an NVFP4 is. When somebody says,
This is absolutely insane, by the way.
FP4 or FP8, it almost means nothing to us. And the reason for that is because it's the
Sorry
tensor
about that. I was
structure
just
and
reading
all
a
the
text
algorithms that make
message,
it
guys. I
useful.
apologize.
NVFP4, we published papers on this already. The precision that the level of throughput and precision it's able to retain is completely incredible. This is groundbreaking work. I would not be surprised if the industry would like us to make this format and this structure an industry standard in the future. This is completely revolutionary. This is how we were able to deliver such a gigantic step up in performance, even though we only have 1.6 times the number of transistors. Okay, so this is, and now once you have a great processing node, and this is the processor node, and inside, so this is for example, here, let me do this. This is, wow, super heavy. You have to be a CEO in really good shape to do this job. Okay, all right. So this thing is, I'm gonna guess, this is probably, I don't know, a couple of 100 pounds. I thought that was funny too. Come on, it could have been. Everybody's going, no, I don't think so. All right, so look at this. This is the last one. We revolutionized the entire NGX chassis. This node, 43 cables, 0 cables, 6 tubes.
Wow.
Just 2 of them here.
That's absolutely insane. This architecture is just incredible, the innovation here.
It takes 2 hours. And of course, you're probably going to assemble it wrong.
It'll probably be much more efficient. Yeah, and yeah, you're right. Heat management will probably be a lot better. A lot better as well. I imagine this entire chassis will be more or less a heat sink. 2 hours to 5 minutes. That's absolutely insane.
100% liquid cooled. Yeah, really a breakthrough.
Much better cooling. So it's liquid cooled.
So this is the new compute chassis, and what connects all of this to the top of rack switches, the east-west traffic, is called the Spectrum X NIC. This is the world's best NIC, unquestionably NVIDIA's Mellanox, the acquisition Mellanox that joined us a long time ago now. Their networking technology for high-performance computing is the world's best, bar none. The algorithms, the chip design, all of the interconnects, all the software stacks that run on top of it, their RDMA, absolutely bar none, the world's best. And now it has the ability to do programmable RDMA and data path accelerator so that our partners like AI Labs could create their own algorithms for how they want to move data around the system. But this is completely world-class, ConnectX. ConnectX 9 and the Vera CPU were co-designed, and we never revealed it, never released it until CX9 came along, because we co-designed it for a new type of processor. You know, ConnectX 9, or CX8 and Spectrum X, revolutionized how Ethernet was done for artificial intelligence. Ethernet traffic for AI is much more intense, requires much lower latency. The instantaneous surge of traffic is unlike anything Ethernet sees. And so we created Spectrum X, which is AI Ethernet. 2 years ago, we announced Spectrum X.
Wow.
NVIDIA today is the largest networking company the world has ever seen. So it's been so successful and used in so many different installations. It is just sweeping the AI landscape. The performance is incredible, especially when you have a 200 megawatt data center, or if you, we're going to invent a new type of data processing. And so Spectrum X is for east-west traffic. We now have a new processor called Bluefield 4. Bluefield 4 allows us to take a very large data center, isolate different parts of it so that different users could use different parts of it, make sure that everything could be virtualized if they decide to be virtualized. So you
can have different clients, I guess, in one data
software,
center.
the security software, the networking software for your north-south traffic.
They're going to have CoreWeave next to
every single one of these compute nodes.
next to
has a second
their own
application I'm
model.
going to talk about in just a second. This is a revolutionary processor, and I'm so excited about it. This is the NVLink 6 switch, and it's right here. This is this switch chip. There are 4 of them inside the NVLink switch here. Each one of these switch chips has the fastest SerDes in history. The world is barely getting to 200 gigabits. This is 400 gigabits per second.
Oh my
switch.
lord,
The
that's
reason why this is so important is so that
insanely
we can have
fast.
Every
Holy
single
crap.
GPU talk to every other GPU at exactly the same time.
And
This
guys,
switch-
again,
this
this is
switch
why
on the
Nvidia's
backplane of
has
one of these racks
the valuation they're
enables us
at,
to
and why
move
they're
the
the
equivalent
most
of
expensive
twice the
company
amount of the global
on
internet
the
data.
stock market valuation
Twice
wise.
as- all
And
of the world's
again,
internet data at twice
they
the
prove
speed.
time and time again
You take the
that they're
cross-sectional
not only an
bandwidth of the
industry
entire
leader,
planet's
but they're
pyramid is about 100
a
terabytes per
constant
second.
innovator in
This
the
is
space.
240 terabytes per second. So it kind of puts it in perspective.
40
This is so that every
terabytes
single
per
GPU can
second,
work with
that's
every single other
absolutely
GPU at exactly the
nuts.
same time. Okay, then on top of that, okay, so this is one rack. This is one rack. Each one of the racks, as you can see, the number of transistors in this one rack
Wow.
is 1.7 times. Yeah, could you do this for me? So it's usually about 2 tons, but today it's 2.5 tons because when they shipped it, they forgot to drain the water out of it.
Funny.
So we shipped a lot of water from California. Can you hear it squealing? You know, when you're rotating 2.5 tons, you're going to squeal a little. Oh, you could do it. Wow. Okay, we won't make you do that twice. All right, so behind this are the NVLink spines. Basically 2 miles of copper cables. Copper is the best conductor we know, and these are all shielded copper cables, structured copper cables, the most the world's ever used in computing systems ever. And our SerDes drive the copper cables from the top of the rack all the way to the bottom of the rack at 400 gigabits per second.
Wow.
It's incredible. And so
That's
this has 2 miles of total
beautiful.
copper
Like
cables, 5,000
aesthetically
copper
and
cables.
just what,
And,
like,
this
you know,
makes
him
the
talking
NVLink,
about it's pretty incredible.
spine possible. This is the revolution that really started the NGX system. Now we decided that we would create an industry standard system so that the entire ecosystem, all of our supply chain, could standardize on these components. The power is twice as high. The power of Vera Rubin is twice as high as Grace Blackwell. And yet,
Wow.
and this is the miracle, the air that goes into it, the air flow is about the same. And very importantly, the water that goes into it is the same temperature, 45 degrees C. With
Wow.
45 degrees C, no water chillers are necessary for data centers. We're basically
Wow.
cooling this supercomputer with hot water.
That's
It's so
absolutely
incredibly efficient.
insane.
And so this is
And
this is the new,
this is
the
going
new
to
rack.
solve hopefully a
1.7
lot of
times more
compute problems
transistors,
with
but
AI.
5 times more peak inference performance, 3.5 times.
And we'll
more
hopefully
peak,
bring down token usage
training
eventually
performance.
as well, depending on the model and who's operating the data
They're
center,
connected on
if
top
my
using
logic
spectrum
is
X.
correct.
Oh, thank you.
That's absolutely incredible.
This is through here. The optics are here, and they connect out to the rest of the data. Key value combinations, but it's a KV cache. Basically, the cache of the longer going to be fast enough. So the answer is very clearly to do it different. And so we created Bluefield 4 so that we could essentially have a very fast KV cache context memory store right in the rack. And so I'll show you in just one second, but there's a whole new category of storage, NVLink 72. So this is Vera Rubin, NVLink 72, 144 Rubin GPUs. This is the context memory that's stored here. Behind each one of these are 4 Bluefields. Behind each Bluefield is 150 terabytes of memory, context memory. And for each
Wow.
GPU, once you allocate it across, each GPU will get an additional 16 terabytes. Now, inside this node, each GPU essentially has 1 terabyte. And now, with this backing store here, directly on the same east-west traffic, at exactly the same data rate, 200 gigabits per second, across literally the entire fabric of this compute node, you're going to get an additional 16 terabytes of memory. Okay, and this is the management plane. These are the Spectrum X switches that connects all of them together. And over here, these switches at the end connects them to the rest of the data center. Okay?
Wow.
And so this is the Vera Rubin. Now there's several things that's really incredible about it. So the first thing that I mentioned is that
This is pretty
this
incredible, I'm
entire
not
system
going to lie.
is
I'm
twice
very impressed.
the energy efficiency, essentially the twice the temperature performance, in the sense that even though the power is twice as high, the amount of energy used is twice as high, the amount of computation is many times higher than that, but the liquid that goes into it is still 45 degrees C. That enables us to save about 6% of the world's data center power. So that's a very big deal. The second very big deal is that this entire system is now confidential computing safe, meaning everything is encoded in transit, at rest, and during compute. And every single bus is now encrypted. Every PCI Express, every NVLink, every NVLink between CPU and GPU, between GPU to GPU, everything is now encrypted. And so it's confidential computing safe. This allows companies to feel safe that their models are being deployed by somebody else, but it will never be seen by anybody else. Okay? And so this particular system is not only incredibly energy efficient, and there's one other thing that's incredible. Because of the nature of the workload of AI, it spikes instantaneously with this computation layer called all reduce. The amount of current, the amount of energy that is used simultaneously is really off the charts. Oftentimes it'll spike up 25%. We now have power smoothing across the entire system so that you don't have to over provision by 25 times, or if you over provision by 25 times, you don't have to leave 25 times the systems and rewriting the entire stack for us to make this possible. Basically,
Wow.
This is training the AI model, this first column. The faster you train AI models, the faster you can get the next frontier out to the world. This is your time to market. This is technology leadership. This is your pricing power.
Wow,
And so
that's
in the case of the
interesting.
green, this is essentially a 10 trillion parameter model. We scaled it up from DeepSeek, that's why we call it DeepSeek++, a training a 10 trillion parameter model on 100 trillion tokens. Okay? And that's the time that we gave it here, which is 1 month.
Wow.
Okay, and so time is the same for everybody. Now, how fast you can train that model. And how large of a model you can train is how you're going to get to the frontier first. The second part is your factory throughput. Blackwell is green again, and factory throughput is important because your factory is, in the case of a gigawatt, is $50 billion. A $50 billion data center can only consume 1 gigawatt of power. And factory throughput is important. Blackwell, it was about 10 times over Hopper. In the case of Rubin, it's going to be about 10 times higher again. Okay?
Wow.
And in the case of now, the cost of the tokens how cost effectively it is to generate the token. This is, Ruben, about 1/10.
Wow, that's what I'm talking about. We're lowering token usage by a 10th.
So
Let's
This is how
go.
we're going to get everybody to the next frontier, to push AI to the next level. Now,
A bright happy green.
World's most powerful AI supercomputer you can plug into the wall.
Scaling laws.
That's crazy. Well, guys, I think I'm going to call it there. The stream went on a little bit longer than I thought it was going to. But no, I had a really good time. This was fun. We'll do another tech stream soon if you guys are up for it. We'll talk about some of the other CES news. But thank you guys for coming in and tuning in. This was fun. I hope you enjoyed it. And